Hi everyone, in this video I want to talk about simplifying square roots with and without variables. Here are the two problems that we'll do, and to make sure that we don't take ourselves too seriously, let's think about the fun question. If someone handed you $1 million today, what is the first thing you would buy? So on the math section, it's likely that you'd see radicals. So that is, first for the ACT, they wouldn't go any higher than a cube root. So a square root or a cube root are fair game in the math section. That would be introduced to you in an Algebra I class. And it's possible that you could see just numbers under the square root, but you could also see a variable or two. And maybe a number on the outside of the square root, like in the second problem here. Okay, so we want to remember a few things. I'm going to take some notes off to the side just so that you remember some of the basics that lead up to radical. So the first is, do you know what a factor is? So instead of doing this 180, let's do something smaller. Like if I asked you to do the square root of 24. Now I want to do it twice. I want to do it with the slow method and the fast method. So we need to remember what a factor is first, and then it's also helpful to remember the list of perfect squares when we do these problems. So perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and I could go on, but I think I might stop just there for now. Okay, slow way. If you remember what a factor tree is, you could do a factor tree, and that would help you figure out the components that would go into simplifying. So 24, is 1 and 12, 2 and, so 1 and 24, 2 and 12, 3 and 8, 8, 4 and 6, and so on. So we have 24, let's just say 3 and 8, just taking it random. 3 is a prime number, so I'm going to circle it. 8, 2 and 4, 2 is a prime number. And then 4 can keep going. 4 is 2 and 2. Okay, so I have that 24 broken down into all primes. That is, it's 2 times 2 times 2 times 3. When I see a double, that tells me that I can square root something. So a 2 times 2 is 4, but square rooted is 2. So I just need to pull out a single 2 when I see a double on the inside of the root sign. What's left over is the 2 times the 3 here. And that just is 2 root 6 as the final answer. That's how you would simplify a 24 square rooted. Okay, now the fast way is looking at this list of perfect squares and thinking, can I use any of those numbers to pull out of the 24 so that I don't need to even mess with all these little numbers, the little factors? I could just find one number that could be eventually square rooted and do it in one swoop. So the square root of 24, I'm thinking, okay, what's the largest one of these numbers that goes in nicely? Meaning, it's a factor, it divides nicely. So that is 4. So I could take this 24 and call it square root of 4. What's left over is a 6. And hey, that's just 2 root 6. So either way I do it, I'm getting 2 root 6, but the fast method is so much better. Okay, so now I'm going to change colors, and let's think about how this relates to 180. So could I forget this slow way and basically use the fast way to do all of these? So 180, I'm thinking, what of these numbers is the largest, perfect square that goes into 180? And I'm going down the list and I'm thinking, hey, 9 goes in. But the problem with 9 is it's not the biggest one. you'd still have a 20 left over. And then the 20 then could still be simplified. So now we need to think about using that list and taking our calculator and going 180 divided by 16 equals 180 divided by 25 divided by 36, and seeing where we get a nice happy whole number. So if you take that 36, you end up getting a 5. 36 times 5 is 180. So a square root of 36 is just 6. Square root of 5 you keep, and that's our final answer for the first one. Now, in the second problem, we have to think about variables a little bit. So for variables, we have to remember the basic concept that like x times x is x squared, right? So that means the square root of x squared is just x. Because the square root is, you're thinking what times itself is that would eventually get you to that product, that x squared. It's x. X times x squared, or I'm sorry, x times x is the x. Okay, so I'm trying to think about how I'm going to handle these variables. That's my hint of how to handle them. But first, let's just work out the number portion of this. So I have my 5. I have my square root of 320. And then there's a product rule that applies to all of this, where if you know that, we have the square root of all 4 of these components, that would be the same thing as taking the square root of them all together. So separated and together would give you the same answer. What I love doing with these radicals is fanning them all out into their smaller parts, simplifying the smaller parts, and then bringing it all back together at the end. So now I've got to work on this 320. Let's see. Maybe I need to take this list out a little bit farther. So 320, if I keep going, past this 36 and I go, okay, 320 divided by 49, 320 divided by 64, and so on. I could get the 64 actually goes in, and that is 5 times. So that whole number portion would eventually simplify down to 5 times 8 root 5. That's just 40 root 5 for the number portion. Okay. Now let's tackle the variables. So if we had, we need to know this information for sure. But another thing we need to remember is that if I took like x to the third times x squared, that's going to be not x to the sixth like a lot of people think. It's basically thinking of 3x's times 2x's, which is, if you count them, it's 5. You would add the 3 and the 2 to getting that. So if I'm thinking about the square root of an even, an odd, and an even, isn't the square root of m squared just m? Yeah, because x times x is x squared. The square root of x squared is just x then. So then we'll bring this down. We don't want to tackle the odds yet. Let's just do the evens because they're easier. P to the 4th, isn't that, we're thinking of what times what, twice, that number twice, is p to the 4th. Isn't it just p squared? So I think we found a shortcut. You can just take this 4 and cut it in half, and you get 2. So this is p squared. Similarly, if we had, let's say, we need to know p to the what times p to the what is p to the 16th. A lot of people would say 4 and 4 there, but it's actually 8 and 8, remember, because you add the exponents. Okay, so now I've gotten most of it finished. We have the m and then the p squared. But this n cubed we need to pull something out that's a perfect square. So isn't an even numbered exponent a perfect square? Yes. And then what's left over is just the 1, because 2 plus 1 is 3. So we have m, square root of n squared is just n, root n, and then we've got p squared on the end. Just a little thought exercise here. If we had, say, kind of going backwards from here, if we had p to the 15th and I square rooted it, wouldn't I need to take out the biggest even, so 14, and then just basically have a 1 as a remainder? So this would be p to the 7th root p. So that's how you'd handle all of those odds. Now, what I said earlier is I like to fan all this out and then bring it back together to one nice final answer at the end. So we have 40 m n p squared, and then what's under the root is the 5 and 1n. Final answer. Okay, so let's have you try some practice. Here they are. So similar to what we just did. Why don't you pause the video, try it, and I will reveal the answers. Okay, answers are here. So we have 8 root 2 for the first one. That means a 64 went into the first one. And then 20xy on the outside, square root of 5yz on the inside. How about a quote for inspiration? Don't let rejection create self-doubt. The founder of Starbucks was turned down by 217 of the 242 investors he initially spoke with. It's a great reminder. So also Michael Jordan was cut from his basketball team in high school. It's a nice tidbit to remember. Just a little encouragement. So I hope this video helped you in some way, and if you'd like to put your answer to the fun question in the comments, that would be great. And feel free to subscribe if you'd like to keep up with videos. Thank you.